Hello, my dear BYJU'S achievers. First of all, I'm sorry for being 3 to 4 minutes late. There was some technical glitch which was happening, but yes, it's sorted now and we are good to go. Alright. So, welcome to yet another session on your own channel and your light chapter. The next session for reflection and refraction, that is spherical mirrors. So, good evening, everyone. Hello, Pranavi, Nibha, Disha, Lakshmi. Hello. Nice, you guys were there in the last session also. Aptha, Sahil, Manoj, Rudra, Amrita. Yes. Good evening, good evening. Kuldeep, Gurkirat, Pranati. Hello. Vijay, Navya, Jagdish. Nice. Yes, Niva, we saw your homework. Don't worry, don't worry. We are coming to it. Hope overall. Nice. Yes, yes. Nirmala, we'll revise also. Don't worry, we'll start with a quick revision and then we'll start with a session. Alright, so, yes. Can just first of all tell me, am I clearly audible and visible to you first of all? Let's just make this thing clear. Yes, Disha. Hey, Srishti. Yes, I remember you. Oh, Ahana. Alright. So, guys, deal is... Yes, Lakshmi. Yeah, please, Sahil. Nice. I'm clearly audible and visible. Very good, very good. Yes. So, one deal is names. No one will request me to take names because the names will always be taken if you ask good questions, if you give good answers. That side, right? You are not able to listen to me. Huh? Is anyone facing any problem with audio? Just let me know because someone is saying that they have audio problem. Huh? No, 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 Ashwati. This is for people who just came in class 10. Right? Nice, all clear. Let's start then. Let's start the revision, or not, I would say revision. Let's start the deepening of understanding of light, the spherical mirrors. Alright? So let's start with the understanding of light. Okay? Nice. The homework question, let's get this thing clear. The homework question, observe the mirrors used in the following cases, identify their types. At platforms on metro stations. Ooh. Yeah, new. So, we'll cover everything. Yeah, this is very important chapter. We have poll questions, Iba. Don't worry. Nice. Correct. Platforms on metro stations, trial rooms in shopping malls, and head mirror used by ENT doctors. So this was the question, right? Correct, correct. Nice, nice, nice. And yes, you guys gave correct answers. And all of your names are also there. So yes, Niba, you were asking me. You are there. Lakshmi, Niba, Yash. And you know what? We love this enthusiasm, guys. I'm really happy when I see all these answers in the chat or comment section. Nice. Yes, that's why. We had Manoj, Chota Bheem, Tanvi, Janvi, Hemlatha, Urvi, Nakul, Anuradha, Srishti, Amrita, Bishal. And yes, you guys have done it well. So, congratulations, your answers are correct. And yes, the first is convex, plane and concave mirror, right? So, that is the correct answer. Anyone, any problem in the homework question? I don't think so, right? Alright, good. So, let's move forward. And before moving forward, I want to show you something, an experiment, a setup which is very good. Some of you might have seen this before because this video we shot with one of my friend. And let's start with a quick video. You watch this video, right? Yes? Okay, I'll just give you a quick explanation over here, right? So, convex mirror, we are saying metro stations. These are used for junctions, right? Where you want to see something which is behind you and it has a broader field of view, right? Yes? Yeah. Right? So, that's why. This is convex. Plane mirrors in the dressing tables and everything. What mirror is there? There's a plane mirror, right? And next, there is a concave mirror, which the ENT doctors use, right? Because what happens? Light, it is focused and they want to see the insides of the ear or the nose, right? So that's the ENT doctors, what they do, right? Don't worry, virtual real image will take. So yes, let's go and watch a video. And then what do I want is, I want you to come back and tell me what happened in that video, right? So, are we ready? All right. So, let's watch this quick video. I won't be there on the screen, all right? Yes. I'm just asking the tech team, are we ready, guys? All right. Come on, watch the video and come back. What do you see? What do you see? What? It's crazy. But how come? What do you see? What do you see? What do you think is happening? Is it magic? What do you think? Like really, I don't know what is it. So. Let me just ask this again. Throughout the video, was there no sound for you? Come on, guys. Let me know. Oh. So throughout the video, you were not able to hear anything you were saying, right? Or was it in between? Acha, sound was there in the end of the video. Okay. Alright. See, which means I would say you haven't missed a lot. Yes. So I would say, what was the setup? There was this whole contraption which you might have seen people were trying to look. So if you remove the bulb from that eyepiece, you could see a bulb over there. Hai na? That was the thing in this video. So, and don't worry, we call it a magic bulb. Yes. Yeah, Niba, this was more like an intrigue. I would say the explanation was not there. Were you able to observe what is happening in the video? It's okay, you were not able to listen, but yeah, explanation will take in this session itself. But could you understand what was the, right? Alright, it's okay. I'll let you watch the video once again. It's okay. It's a short video. Go ahead and watch it. Come on. And okay, so you can see a weird little setup in front of you. Yes. The only thing I want you to look at is this light bulb. Okay. Cool. Now you'll see a button in front of you. I want you to press that button and see. Bulb is glowing? Yes. Yeah. Fine? Yeah. Press it again. You will see. Yeah, cool. So now I'm going to remove this bulb. Press it again. Nothing's there. Yeah. So nothing's going to glow. Yeah. Cool. Now you'll see a hole in front of you. Cool. Look through that hole. Okay, and press the button. What do you see?
There is a bulb. So maybe.
What's happening? What do you see? What do you see?
do you see? What do you see? What do you think is happening? Is it magic? What do you think?
Like really, I don't know what is it. Yes. This time, were you able to observe what was happening? Right? Could you see that reaction from the faces of people? And they were all like people from office. So we did this shoot in the office itself. Yes. Nice. Nice. Yes, Hema. And yeah, Hema, I saw your comment. Don't worry. We'll revise everything. But this time, this is what we are saying, a magic ball, right? And magicians pull off these tricks, and the moment you understand what's the science behind this, the magic is no longer magic. It's science. But until you understand the science behind that trick, it's magic. Right? Something which you are not able to understand, right? So that's why, don't worry. Correct, Disha. You are correct there. But yes, don't worry, we'll discuss about what is the science behind this experiment. But yeah, I hope you enjoyed it. Yes, we'll keep doing such things more and more, right? Yes, the content, what we'll revise today or what we'll discuss today will be reflection of light, spherical mirrors, image formation by spherical mirrors, and application of spherical mirrors, all right? Yes. Nice. Correct. Guys, chit-chatting among you, I would say, hold on. Focus, you and me only over here, right? Yes. Yes, come on, nice. Kuldeep, don't worry. Names, what will you do with names? I understand. If you ask me good questions and good answers, the names will be taken now. If I just keep taking names in the session, it's irrelevant now, right? Education world. They are good to solve, right? Lakshmi, it's speed of light. Don't worry. We'll talk about this. So let's start with a quick revision. So people who were asking, like Hema, you were asking what revision? So yes, this is a quick revision of whatever we have discussed till now, right? Reflection of light. What is reflection of light? The bouncing back of light into the same medium after striking the surface, right? So that's why. When light falls on a surface and reflects back in the same medium, that is what we are saying as reflection of light. Simple, hai na? So there are two important laws, right? It's okay, Kuldeep, don't worry. It's okay not to be sorry here. Yes? Yes? Alright. Come on. The first law. If this is my reflecting plane, this is like a mirror kept flat, right? And the first law would be, alright, first let's see the terminology. This is the incident ray. The light ray which is falling on the mirror is the incident ray, and which gets reflected back is what we are calling as the reflected ray. Fine. Now, this imaginary line which is at 90 degrees from the surface of the paper, or not sorry paper, the reflecting surface, this imaginary line which is 90 degrees from this plane is the normal, right? Yes. Bending is refraction. Yes. Alright, so this. With the normal, the angle which is formed between incident ray and the normal is what we are calling as the angle of incidence. Between the reflected ray and the normal, it is the angle of reflection. Fine? Yes, I and R. So, the laws of reflection say, first, angle of incidence will be equal to the angle of reflection. If it is reflection from any surface, this law will be followed, right? I will be equal to R. The only mistake which you can do is, make sure you see that I is the angle you are noticing between normal and incident ray, right? Never ever take this angle. Fine? Okay? Nice. Oh, nice, Harshita. Alright, okay. The next law. Incident ray, reflected ray and the normal lie in the same plane, right? There was a good question in the last session, I remember. Sir, why normal is taking with the plane, right? Like 90 degrees of the plane. Can't we take any other normal? So this second law is basically helping you out. Normal is like this, incident ray is like this, and reflected ray like this. So all these three rays are in one plane. So that is the second law, right? So this is the two laws of reflection. Alright, good. Oh, Disha. It's there in the premium, right? Taking the shortest time. Alright. Yes, good. Menti, not today, Ujan. आज animation पे focus करते हैं ना, right? Let's focus on animation. Let's focus on understanding. Menti is good for quiz. Yes, normal will always be perpendicular. Correct, Hema. Yes. Alright. Okay. Next, image formation by plane mirror. So this is how we started in the last session also. Na? Laws of reflection. Then you start with plane mirror and then you go for curved surfaces, right? So image formation by plane mirror. Can someone tell me properties of image formed in plane mirror? Come on, people who know this. Principal axis की जरूरत क्यों पड़ती है? Don't worry, I'll talk about this. It's a good question though. Yes, okay. Laterally inverted, virtual, yes. Same size, nice. Same size as object, good up. Erect, nice. Correct. So, virtual, erect, same size and same distance also, right? Equidistant, correct. Nice, Hema. Yeah. So all these are properties of image formation in plane mirrors. See, in plane mirrors now, whatever question is there, if these properties are clear to you, you can solve any question, any type of question, I would say. But we need practice for that. Don't worry, we'll have question session also and we'll practice all these things. So object size equals image size. The object distance equals image distance, and image is erect, laterally inverted and virtual. Simple, easy, something which is very, very easy to understand. Don't worry. Alright. Now, what happens when you take a single plane mirror and you put multiple plane mirrors like this, right? A curved mirror forms a different perspective. What am I saying here? I'm trying to say a curved mirror is nothing. It's just small plane mirrors which are joined and made into a curve. Yeah. See, focus, principal focus. Don't worry, we'll discuss all these things. Let's not rush into things. No, let's start step by step. Right? Yes, it's concave mirror. So when you keep on adding the mirrors, you get a curve, an irregular curve, right? But more small mirrors, it's actually a part of a sphere. Right? Characteristics regarding image formation in plane mirror. It's same, right? Equidistance. From the mirror, how much far the object is, the same distance would be of the image. What is the size of object? They're the same size of image. Virtual, erect and same size. That's true. Yes. Harshita, yes, you definitely. The concepts will remain same. Hai na? Board mein kya hai ki the concepts are almost the same. So we are dealing with basics. So whatever basics are there, learn them, understand them, and yes, it will also be helpful. Hey. Right? Yes. So, it's a part of a sphere. So, whenever you talk of spherical mirrors, spherical word is coming from sphere. Sphere means it was a sphere first of all. Then you cut that sphere from different places and polish some surfaces and you will get convex and concave. So, what I'm saying here? Yes. So, Harshil, I'm saying that a curved mirror is like a combination of infinite plane mirrors joined to form a curve. Or you can say, if you have a sphere, small plane mirrors. So that is what forming a sphere. So imagine that there is a sphere and from that sphere you cut things. How do you cut things? If let's say this is a ball and you cut from here, what do you get? A kind of a mirror. If you cut from here, this is again what? A kind of a mirror. So you just take these two parts separately and then this becomes a concave mirror. So what is a concave mirror? And this we have done before also. What is a concave mirror? It has a reflecting surface inside, right? Reflecting surfaces inside. So two types possible, no? Like this or like this. So if reflecting surface is inside wala, it's a concave mirror. Means you have to polish the other side. This one. Fine. Don't worry, magnification will do. Yes, correct. And if you are polishing this side, means this side will become reflective. Now it's a convex mirror, right? Got it? Yeah, Ujan, it's okay. Yes. Concave is converging. Don't worry, we'll talk about this. So reflecting surface curved inwards is concave. And you know what? What helped me a lot is the terminology. Concave. Okay. Something like a cave. Something deep. Okay. That's why. This is concave. Convex. Vexed means like something swollen or something protruding. So that's why. Vex becomes this. Convex. Alright. Okay. So you can use these kind of terminology also. Not a problem. Yes, concave is converging and convex is diverging. That's true. Nice. Good students. Alright. Vice versa in lens. Correct. So, the mirror terminology, let's see. It was a part of sphere and that's why spherical mirrors. So, we'll take a principal axis. Now, what is principal axis? If let's say this is a mirror, this center point will be pole. And from this pole, the line going is principal axis. Okay? Hema, so focus. If you had confusion, it is in the past. The present is discussion. Present is learning. So focus on present. Yes? उजान हिंदी देखो हिंदी इंग्लिश इतना डिफिकल्ट नहीं है लेकिन मैं चाहता हूँ तुम इंग्लिश में भी समझो बिकॉज टुमारो व्हेन यू गो टू कॉलेज एंड एवरीथिंग यू नीड इंग्लिश दैट्स व्हाई घर पे तो हिंदी में बात करते हैं ना बट हियर लेट्स डिस्कस इन इंग्लिश बट वेरेवर यू हैव प्रॉब्लम लेट मी नो आई विल ट्रांसलेट यू टू हिंदी आल्सो इन बिटवीन ठीक है यस गुड सो नेक्स्ट this line is what we call as the principal axis. All right, fine. Now the different points. This point, the center of the mirror, is what we are calling as the pole. If this is the whole mirror, this center point is the pole, and the line from the pole perpendicularly going outward is the principal axis. Fine, nice educational repository. Very good. That is pole. Correct. Then there is center of curvature. So what is center of curvature? The sphere from which the mirror was a part of. है ना? ये mirror जिस sphere का part था, उस sphere का center, right? This mirror was a part of one sphere. The center of that sphere is what we call as the center of curvature. Fine. Okay. Alright. So this is the center of curvature. And the distance between pole and center of curvature is the radius of curvature. So this is easier to understand, right? Pole kya nibha pole is easy. See, if this is your mirror, the center point of the mirror is the pole, and the line from center point of the pole is what we call as the principal axis. Okay? Got it? Yes. Now, let's see. What will happen to a paper placed in front of a concave mirror placed in sunlight? I don't know if you have tried this. I mean, if you get a chance to, get a hold of concave mirror. Oh, nice, Ashu. Ashu, I would say you interact in these sessions. You understand whether if you have learned is correct or not, and then you practice questions. So that is important, right? Yes. Yes. Nice, you have tried, huh? Very good. Nahi, Nibhana. Pole and center of curvature are not the same thing. See, pole is the center of the mirror, and center of curvature is the point, or basically is the center of the sphere which this whole mirror was a part of, right? Your mirror was only this much, na? If this was your mirror, then it was a part of some sphere. Center of that sphere is the center of curvature, right? And the line joining center of curvature and pole is the principal axis, you can say, right? Yes. Very good. Nice. So, light is converged at a point as a sharp, bright spot. Object is at infinity. Sun is where? Very far. So, light rays are coming from infinity, falling on this mirror and getting converged on a point. And this is the point where the burning will happen, right? So this is what we do. The light is converged at a point as a sharp, bright spot. What is the significance of this spot? Tell me, what is this spot called as? Can someone tell? Yes? This shade is 3D, no? You can hold it. So it's a 3D thing. Nice. Not blind spot. Focus. Yes. This is the focus. And yes, principal focus, I understand where you are confused. Don't worry, I'll tell this to you. Right? Yeah, I would say focus is a better word. Principal focus is, see, you can have multiple focus points. How do I tell you this? See, if this is a concave mirror, na? And this point is the principal focus. So principal focus is the focus lying on the principal axis. But there is this plane, na? If this is the mirror and this is the point, the principal focus, if I draw a plane over here, so alag jagahon se, whenever you pass light like this, it will form a point focus over here, right? So that's why. Focus could be many points, but principal focus is the special focus which is lying on the principal axis. Tick. Got this? Yeah, Hema, kind of. Pole is for you the center of the mirror. If this is your mirror, the center of mirror is the pole. Alright, good. Nice. So principal focus, point where a light rays converge after reflection in a concave mirror. So do you see? Principal focus, all these rays which are parallel to principal axis, they will converge on the principal focus, right? The focus lying on the principal axis. Ashu, it's a convention, right? It's a convention. We just take left to be negative, right to be positive. That's why we say U is negative. It's not something hard and fast rule, I would say. Alright, nice. So this is the principal focus. Then we have point where light rays diverge after reflection. What happened here? When the parallel rays came, they got diverged. But if you look from here, you will see that light is traveling in a straight line and appears to coming from a point behind the mirror, and that is the focus, right? So this is what? It's a virtual point. Light rays are not actually meeting. Yes? Correct? So principal focus mein kya hua tha? What happened in principal focus? The light rays parallel to principal axis, they were converging on a point. They were actually meeting on a point, and that was the principal focus in case of concave mirror. Convex mein kya hota hai? They will fall on the mirror and get diverged, right? They get diverged like this, as it is happening over here. Watch. But behind the mirror, they appear to be meeting, right? Appear, right? Laterally inversion, Shubham, इसमें कुछ है नहीं. If you raise your left hand, the image person looks to be raising his right hand. इसको बोलते हैं lateral inversion, but it's something. We'll do questions and then you will understand which characters will get laterally inverted and which will not. For example, H will be inverted, H will not be inverted, A will not be inverted, but B will be inverted, right? So the basic properties will tell you the lateral inversion, right? Don't worry about this. No, Sanjana, it's infinite. Alright, so guys, let's go and perform, or let's watch a good simulation to understand better what we are doing. Alright, come on, let's do it. No, it is behind because they are not actually meeting. Na? Parallel rays will fall and they will diverge. They will not converge. Na? Okay, got it? Nice. So let's go and understand or watch this simulation. Yes. Let's see. Time machine. Huh? All right. Can you see the simulation on the screen now, guys? Let me know. No, I don't think so. You can see it. Yes, it is this one. All right. So focus. Come on. Dual nature. Because that's what I like, Hardik. All right. So watch. Rotate the laser using the slider and observe how the beams interact with the concave mirror. So this is a simulation. Watch very closely, right? What happens? Yes? No, learn along with me. It's not necessary that you can only see real images. You can see virtual images. That's true. Correct? So watch. If I change the angle of the laser, watch. So what is pole doing? It is the center point of the mirror. It is dividing mirror into equal halves. If you take a 2D thing for this, that's why the ray of light will follow the laws of reflection, and that's why this angle will be equal to this angle, and that's why it will symmetrically get reflected back. Take first one, a parallel ray. If a ray parallel to principal axis falls on the mirror, it is bound to pass through the principal focus. Take, right? Nice. Thank you, Ananya. Yes, they are. Harshita. Second one we have done. Third one, let's see. If a ray which passes through the focus and falls on the mirror, it will become parallel. Right? Yes? Cool. The light rays incident through focus travel parallel to the principal axis after reflection. And yes, all these things are there in the BYJU'S Premium, right? If you want to try them, just download the app and you will see there are a lot of games and all these things over there. Yes? So this simulation is trying to discuss or understand you the different or special rays. The last one would be, this is important. Center of curvature is the center of sphere of which concave mirror is a part. So when a ray passes through center of curvature and falls on the mirror, it will reflect back. This is interesting. Can someone tell me why does it reflect back? Why does this ray retraces its parts back? Yeah, right? Why only at focus, Jagdish? ऐसा क्यों होता है? This is how you have observed, no? जब चीज fall करती है और एक point पर converge करती है. So if you start from that point, it will become parallel, na? Right? Right, come on. Nice. It is normal for a spherical mirror. Yes, it is normal. That case, this center of curvature wala case is what? If surface is there and light ray falls normally, it goes back. So from center to, from center of curvature, if you draw a line and fall on the mirror, it will be 90 degrees, right? Yes, it is perpendicular to the point. Very good, Yash. Nice. Sanjana, good. Learn along with me. It's there, guys. Don't worry. These are questions in between. Yes? 90 degrees. Very good. Very nice. So, let's see the question. A normal line for all the reflections in the spherical mirror passes through dash of the mirror. Tell me. The normal line for all the reflections in the spherical mirror passes through dash of the mirror. The thing which we just discussed. Tell me, focus, pole or center of curvature? Pole, focus? Guys. Yes. What is this point? This white point, tell me. Can you see the options? Center of curvature. How come focus? If it would have been focus, the light would have become parallel. But light is not becoming parallel, right? So if you say focus, I'll do focus. Yes. Center of curvature. Correct. Come on. Understand this. The point was, light was falling, 90 degrees coming back. So it was center of curvature. How could it be focus, right? It's okay, Aditi. Shruti, center of curvature, say if you drop a line on the mirror, it will be 90 degrees. This case is more like when a line falls perpendicular on a mirror, right? Fine. All right, good. Let's move back to the session. Cool. Yes. So what did we learn? The special rays for a convex mirror, same kind of thing. Same kind of thing. A parallel ray will get diverged, but if you retrace it back, you will see it is coming from a point that is the focus for the convex mirror. Alright, next one. A ray which was pointed towards focus, it will reflect from the mirror and become parallel, right? So this will become parallel, right? Fine, okay. Third one, a line which was pointed towards center of curvature will fall on the mirror and come back. Take, fine. Focus definition, Hema, would be the light ray after reflection from the spherical mirror either meets the light rays either meet on this point or they appear to meet at this point behind the mirror, right? That is the focus. Yes? Alright, so yes, these three are important rays in terms of convex mirror, alright? So they are not difficult to understand. See, if this was my convex mirror and there was a focus, so when you point a laser towards focus, the light will fall on the mirror and become parallel. If you point towards center of curvature, what will happen? It will go and come back. Take. What is focus and principal focus? See, focus is any point on the focal plane, if I would say, right? You know this is focus, right? So this is a plane, I would say. So focus could be any point, but principal focus is the point which is lying on the principal axis. Right? Yes. So I think this much is fine. And here we have a small poll question. It's not a difficult poll question. If an incident ray, if the ray is on principal axis, what will happen? Think. If the ray is on principal axis, it will go and come back. What is there? Just see where it is falling, na? Yes? So, if an incident ray passes through C of the mirror, then the reflected ray will pass through the dash line. Okay. Tell me. This line you have seen. Now, which colored line will give the correct answer? What will happen, right? So, let's start the poll and I'll give you 30 seconds. Your time starts now. Right? Tell me. I can see yellows, some few reds, blue. Alright. This is very easy. Yeah, you're right. It's quite easy. Right? Nice. And yes, guys, you are correct. Light is passing through center of curvature. It will fall on the mirror and come back. No, it will retrace its path. Which light is doing it? Yellow one. So that's why the answer would be option B. Yellow. So let's do this very quick thing. Blue is not the answer, Lakshmi. It's yellow. Blue was not correct. Nice. Correct option 1. In the same medium, correct. Yes. So, how do you see things around you? Because from some source, light falls on that particular object and it reflects, right? So, let's say for you the source is sun. Sun ray, yes. So, from that object, light rays are getting reflected in all directions, right? If you can see, let's say, if you can see this pen, and let's say it's not black, it's shiny, hai na? So it is giving light off in all the directions. But if you want to form an image of a point, how many rays do you need? Can someone tell me this? Minimum how many rays you need to form an image of a point? It's an important question. Tell me, come on. Someone. 3, 2, yes. 2 rays are enough. If you want to form an image of a point, 2 rays are sufficient. That's correct. Very good. So, if you take 2 rays, from that point, you will get an image of the point. That's enough. From the tip, you take the 2 rays. Guys, we are learning how to make the ray diagrams over here. Hai na? If you have a convex mirror, then see what happens. You will make all the points, right? On this side, CF, CF. It's okay, Hima, I understand that. So, Aditya, at least you need 2 rays to form image of a point. Then, what do you see? You will take 2 special rays. Hai na? We have learned in this session what are the special rays. Rays which are parallel, rays which are pointed towards focus, rays which are at pole, rays which are at center of curvature. You can take any of those rays and you will find that if you follow the rays properly, you will get the same point every time. So here I have taken 2 rays. One is the parallel one and this one is the center of curvature one, right? So I have taken 2 rays. Now my understanding says, what happens to a parallel ray? Tell me, what happens to a parallel ray? The parallel ray gets reflected back such that it was coming from focus. The ray towards center of curvature retraces its path back. I will draw the line, and where these 2 lines are appearing to meet, they are appearing to meet over here, and that's why that is my image. Okay, nice. Got it? Very good, very good. So from the tip you take two rays and follow the special rays property. That's it. Okay, got it? Very good. Thank you, Arshita. Nice. So image formation in convex mirror. In convex mirror, if you say all the rays parallel falling on the convex mirror, they appear to be coming from the focus. Alright, next one. What do you see? Any ray which is between infinity and pole, right? It will form image something like this. So in convex mirror, guys, this is a chart, right? This diagram, this diagram is simple. See, two rays you have taken. This is the parallel one. It will go like this, from coming from focus, and center of curvature one will retrace his path back. So that's why they both appear to meet over here, and that's why this is the virtual image, right? So this is an important table which comes every time, right? Which comes every time. Where is infinity? It's Priyanshu, it is very far. It's very far, I would say. So that is the infinity. Image formation in convex mirror, position of object, image position, image size, and image nature. In case of convex mirrors, you get whenever the object is at infinity, it's very far from the mirror. You get position at focus, image size is highly diminished, and nature is virtual and erect. If any other position between pole and focus, diminished and virtual erect image. So, in convex mirror, what is happening? You are every time getting virtual erect image, a diminished image, right? So that is something, convex mirrors, right? Yeah, diverging mirror, convex mirror, same thing, yes. Yeah, imaginary, we don't use the word imaginary, we say virtual, right? Yes. So, this table is quite important. What I want from you guys is, once this chapter is over, make such a table and paste it, or just wherever you make a cheat sheet out of it, because these things are very important. You can get infinite questions on such properties, so don't worry. Right? Cool. So applications of convex mirror, this is something which we have. So today's session is more like a plus thing from the bridge session, right? Surveillance safety mirror, because it covers more area, it has wider field of view, right? Why sunlight forms a focus which is not point size? It is, yes, it should be, right? So, I'm saying convex mirror always form image inside, means virtual, erect and diminished. When the object is at infinity, it's a point size image. When it is between infinity and pole, it's a virtual, erect and diminished between pole and focus of the mirror. Cool, nice. Surveillance and safety mirror, rear view mirror, again the same thing, right? You want to see more area, what is behind you, you want to see a virtual image, you want to see a erect image, right? So that's why. Wide view mirror, this is again wide view, wide field of view, right? So that's why. Ray diagram for a rear view mirror, watch. You have taken 2 points only, na? This is the focus, again this is center of curvature one, and that's why you got a smaller image, and that's why real, convex and concave. Wow, Lakshmi, it's a big thing you have asked, and don't worry, this whole session is going towards that, right? So convex and concave mirror, you know, yes, always diminished, and when things are small, you get a feeling it is far from you, you know? If you keep your finger close to your eye, you see it is big. You take it far, you see it is small. So that's why in the mirror it is written that objects are much closer than they appear. That's why. Object's image is always between pole and focus. It is diminished. Yes, fine. In one mirror, there will be both concave and convex. No, why? Yes, in convex mirror, object is always, image is always diminished, alright? Nice. Yeah, Neo, don't worry, we'll have something planned for you. Okay, so in concave mirror, let's do this thing very quickly. In concave mirror, this is again a small simulation we'll do, alright? Seema, in one sphere, so both came from one sphere, is just the place from where you cut and the place from where you polish. That's the only difference, alright? Yes, and don't worry, Neo, the answer to your question will come soon on the channel. So image formation in concave mirror, let's do a simulation on this, don't worry, alright. Yes. Let's see. It's a game, I would say. There is a story in this. Lucas was on a scientific exploration near mysterious caves when he gets attacked by a group of supernatural monsters. And this is a good story. Focus and try to answer. Session will be over in next 5-7 minutes. So these are the supernatural monsters. There is a huge sized concave mirror inside the cave to form the image. Help Lucas capture the monster. He runs towards the mirror, right? So how do you catch a monster? If you can find the point at which the image would be formed, and that's how you have to catch the monster. Take. So, all right. Look, the monster is beyond C. This is my concave mirror. Position the magic canvas to capture the image of the monster. So tell me, where should I move the canvas position? Should I move it at F? Should I move it between C and F? Should I move it at C, or should I move it beyond C? Tell me. So you should have this knowledge. So you have learned these things in the previous classes, na? Where the image would be formed. Tell me, remember that knowledge? Nice. Nice. Between C and F. Okay, let's see. Between C and F, if I submit, then Lucas has pushed. And yes, oh, you have captured the monster. Very good. Nice. Very nice. The monster is captured when an object is beyond C. So when the object is beyond C, the image is formed between C and F. Its image is formed between C and F. Alright, good. Next one, very quickly. Let's do. This time the monster is between C and F. Oh, so where should we? Sidhu, let's explore this, and focus on the rays. There are two rays taken here, the parallel one and the focus one. So when the monster is between C and F, where will the image be formed? F you are saying, huh? Okay, let's see. Some people are saying F, so for the sake of understanding, if I put it F, oh no, that's not correct. Yes, try again. So when so you know what? When the object is beyond C, image is formed between C and F. When the object is between C and F, image is formed beyond C. Beyond C, right? And watch the ray diagram. Right? The monster is captured. Okay. Let's practice again. Next one. This time the monster is at infinity. And what did I say? When something is at infinity means it is far. And we can assume the rays are coming parallel to principal axis. Tell me, the monster is at infinity. Where should I position the canvas? At focus. Let's see if F is the correct thing. Nice. Very good. At focus. Nice. Very good. Monster is captured. Let's try some other thing. Okay. This time the monster is at center of curvature. What do you think? Center of curvature. Nice. At center of curvature. Same size, real, inverted, same size image at center of curvature. And that's how you will capture the monster again. Nice. Very good. And do you see, this canvas, you are capturing all the real images, right? So real images you can capture on screen. Nice. The last one. The monster is at focus. So till now, did you notice all the rays after reflection, they were actually meeting on the same side of the mirror. But here now, watch. He is at focus. Yes? So what do you think? At infinity. True, yeah. Nice. Good batch you are. Very good. So at infinity, let's see if it is correct or not. At infinity. Lucas has to run all this way to take the canvas till infinity. Nice. That's the correct answer. So with this, I would say you have revised all your concave mirror image formation things. So this was a good way, to learn these things. Nice. So let's get back to the session. Alright, so image formation in concave mirror. So believe me, the way you have learned it, it's actually better than cramming this table over here, right? So that's why I'm saying, don't be scared of this table. This is pretty scary and people tend to forget this a lot. I'm just saying, just enjoy the learning, right? So yeah, it can come for board exam, right? So I'm saying, once this session or the chapter is over, I would say draw a table, stick it at the wall, and whatever cheat sheets, placards you want to make, just make them, and have a habit to just give at least 2 minutes every day. Fine? Thank you. Simulations, yeah, that's our strength actually. Yes, okay. So application of concave mirror, dentist mirror, solar furnace, and torch. You say different things you can actually use, and you will find these amazing applications of concave mirror. Nice, very good. So ray diagram for dentist mirror. This is a special case between pole and focus. What happens? You see an object and then the rays cannot actually meet on the same side. Means if you trace them back towards the mirror, you will get a virtual, erect and magnified image, right? Yeah, I have next session too. Teachers have come in the studio actually. They are waiting for me to finish. Yes. All right. So this is about a dentist mirror. You want a virtual, erect and magnified image, right? So converging mirror, same thing. I would say I'll just run it through now. Torches may, if you keep a bulb at the focus, what happens? You will take it to the, yes, it will reach to infinity. Nice. So a very quick explanation of the magic bulb thing. Just watch this and we'll end the session. Come on. Just tell me, is it audible to you, the video? Nice. Sound is not audible to people. It's echo, you are saying. It's okay, don't worry. The explanation video will take in the next session. Till then, just think what could have been the answer. All right. Now it's okay, right? Cool. So just take this screenshot of this homework question, and next session it will be like 2-3 minutes delay over here. So I'm just telling you upfront. So just hold on and take the screenshot. And the explanation video we'll talk again in the next session. The first thing we'll do in the next session is talk about the explanation video, right? So don't worry about this. Nice. Thank you guys for joining. And yes, sorry for the glitches which happened in the session. Don't worry about this. Thank you. So we have got you covered, trying to get you covered, and we have, you know what, the next session on 29th April. That's Friday. I'll see you then. Right? Take care. Bye-bye. Have a good day.